Section 2.3 deals with solving inequalities by multiplying or dividing. So our warm-up today consists of 4 problems where we are simply solving an equation and 2 problems where we are graphing inequalities. All right, so let's check our work here. Number 1, a equals -6. Number 2, x equals -10. Number 3, y equals -15/8. And number 4, x equals -8/11. For graphing our inequalities, our target number in number 5 was -10. We needed a closed circle because of the or equal to, and it was greater than, so we shade to the right. In number 6, our target number was -3. An open circle, shade to the left. So our goals for today are to be able to solve one-step inequalities using multiplication and also using division. Now, much like our previous lesson, we're going to be using our same ideas in terms of solving equations as when we're solving inequalities. But there's one thing that we're going to be on the lookout for a little bit later on. So we're going to be using our inverse operations. So if we take a look at example 1, we're solving 7x is greater than -42. I'm going to try to continue putting our dotted line through our inequality, circling our variable. Some of us still need to make sure that we practice that. And now, in order to get rid of that 7, which is attached through multiplication, we are going to divide both sides by 7. We would technically call that the division property of inequality. Okay, so that now we have our answer of x is greater than -6. So we locate our target number of -6 on the number line. It's going to be an open circle, and we shade to the right for our greater than. In number 2, our variable is on the right-hand side of our inequality, and that's perfectly fine. We're going to solve it and isolate the variable on the right, and then we'll flip it around at the very end. So I'm going to put my dotted line through my inequality, circle my variable. I need to get rid of the divide by 3 by multiplying both sides by 3. So 3 times 2.4 is going to give us 7.2 is less than or equal to m. Okay, so leave everything in its position until the very end. Now we're going to flip the whole thing around, which would then say that m is greater than or equal to 7.2. Okay, so notice our inequality is still open to the m. So we need to locate 7.2 on our number line. So here's 7, so it's just going to be a little bit more than that. It's going to get a closed circle, and we shade to the right. Again, I apologize for these tiny little number lines. Just trying to fit as much in as possible without using up too much space. And let's look at number 3. Number 3 says 3/4 r is less than 12. Now, some of us go about this in different ways. Now, in a perfect world, you'd say, oh, well, we need to multiply by the reciprocal, because technically 3/4 is being multiplied by r, so we would divide both sides by 3/4, which means we're multiplying by 4/3. Now, if you show that you're simply dividing both sides by 3/4 and do that in your calculator, that's technically getting the job done. But I prefer to do it using a more sound mathematical, mental type of process. So in doing so, we then get r is less than, that's going to end up being 16. So our target number is 16. It gets an open circle, and less than is shading to the left. Another way that we could actually go about doing number 3 would be, we could write this as 3r over 4. is less than 12. So you could actually start off by multiplying both sides by 4 to get rid of that divide by 4. So now you have 3r is less than 48. And then divide both sides by 3. So you could also just split it into 2 steps. I probably actually like that better than using the calculator and showing that divide by a fraction. So r is still going to end up being less than 16. Okay, so that's an option 2. All right, I'd actually like you to go ahead and do numbers 4, 5, and 6 using our inverse operations of multiplication or division. And again, be careful with number 5. Okay, number 5 is going to be very similar to number 2 in that our variable is on the right side, so isolate on the right, that's perfectly okay, and then flip your overall final answer. Okay, so let's check our work, see how we did. Number 4, we should have k is greater than 6, open circle on 6, shade to the right. Number 5, when we isolated q on the right-hand side, we had negative 10 is greater than or equal to q, which therefore means that q is less than or equal to negative 10. Closed circle on negative 10, shaded to the left. Number 6, I still am using my multiply by the reciprocal approach to see that cross cancel, the 4s and the 3s. We end up with g is greater than 36. So we approximate 36 on our number line. Open circle, shade to the right. A way that we can check our work, just as a reminder from the previous lesson, we can check our target number to make sure it's correct by plugging it into the original and pretending it's an equation. So if I take 6, plug it in for k, 4 times 6, does it equal 24? So yes, 24 equals 24. We can check our shading by picking any number that we want that would be in our solution set here, so any number bigger than 6, and plug it into the actual inequality and make sure that it works. So I'm going to take 10. We could plug in 100 if we wanted to, but I'm going to take 10, plug that in, and do 4 times 10. Is it greater than 24? And yes, 40 is greater than 24. Okay, so you kind of almost need to do a double check, checking your target number and then checking your solution if you really want to be thorough. Okay, so we've got one little but very, very important addition when we have solving inequalities by multiplication or division. So that states that if we multiply or divide both sides of an inequality by a negative number, the inequality is no longer a true statement. Okay? And in order to make it a true statement, I don't need that part highlighted, we need to flip our inequality. Okay, so any time we multiply or divide both sides by a negative number in our solving process, we need to flip our inequality symbol, just the symbol itself. Then that inequality statement will remain true. Okay. Now here's an example here that says beware. So here's an example where in order to solve, we would divide both sides by 4. And yeah, we have a negative 24 over there, but the solving process is dividing both sides by a positive 4. We need to flip when we're dividing both sides by a negative number or multiplying both sides by a negative number. Okay, so when that inverse operation is multiplying or dividing by a negative. So number 7, okay, is going to be our first problem that addresses that. So I'm going to circle my variable, dotted line through our inequality, and now we would say, okay, well, the negative 12 is attached to the x through multiplication, so we're going to divide. So I need to divide by negative 12. And because I divided both sides by a negative number, that means I need to flip my inequality symbol. So actually I usually circle that as well. So I kind of circle the fact that dividing both sides by a negative, circle the inequality, reminding myself to flip it. So now it's going to say x is less than negative 7. Target number is negative 7. Open circle, shade to the left. Number 8. Dotted line through our inequality. Circle the variable. X is being divided by negative 3. Therefore, to undo that division, we need to multiply both sides by negative 3. And I'm going to show that using the parenthesis version of multiplication, just so it doesn't look like we're subtracting 3. Okay, so because we multiplied both sides by a negative, I'm flipping that inequality. I'm going to leave everything in its position until the very end. So negative 3 times negative 8 gives me positive 24, is greater than or equal to x. Okay, so we had to flip that inequality symbol, but now I'm going to flip the overall answer because I want my variable first. So then x is less than or equal to 24. Target number of 24 receives a closed circle right around here. And we shade to the left. In number 9, dotted line through our inequality. Circle our variable. This is like having a negative 1 times x. So to undo that negative, let's divide both sides, or to undo that multiplying by negative 1, we're going to divide both sides by negative 1. So we divided both sides by negative 1, so we've got to flip that inequality symbol. So now I've got a negative 10 on the left. Instead of greater than or equal to, it's now less than or equal to, and then we've got just x remaining on the right. Cancel those inverse operations and flip the whole answer around now. X is therefore greater than or equal to negative 10. Okay, so negative 10 is our target number. It gets a closed circle. And we shade to the right. Okay, so let's do a quick check with that one. Let's check our target number first of negative 10 by plugging it directly in. So is 10, and remember checking target number, you do it like an equation, is 10 equal to the opposite of negative 10? Well, negative times a negative is a positive, so 10 equals 10. Target number checks out. Now let's check one of our solutions in our solution region. So any number bigger than negative 10. I like to choose 0 whenever possible. So is 10 greater than or equal to negative, or the opposite of 0? Well, there's no negative 0, so is 10 greater than or equal to 0? Yeah, that's true. So we are shaded in the correct direction. I would like you to give number 10 a try. Be careful with the fact that A, we're going to be dividing by a negative, and also our variable is on the right side. So make sure you keep everything in its lane until the very end, and then fix things up and put the variable on the left. All right, so hopefully we divided both sides by negative 0.25, which gave us negative 17 is less than, because we've got to flip, h. We then rewrite our whole answer with our variable first, so h is therefore greater than negative 17. So open circle on our target number of negative 17 on the number line, shade to the right. All right, now we have a couple word problems here. Number 11 says that Jill has a $20 gift card to an art supply store where 4-ounce tubes of paint are $4.30 each after tax. What are the possible numbers of tubes that Jill can buy? So the fact that they're 4-ounce tubes doesn't really matter. Okay, so that number of 4 is kind of irrelevant. So if I were to word this as the tubes of paint it's $4.30 per tube. Let's try to write it that way. It's an easier way to describe it. So the cost is $4.30 per tube. And our word per means we are multiplying. So what we need to do in order to determine what her total bill is going to be, we're going to multiply $4.30 times the number of tubes of paint. And she only has a $20 gift card, so she can spend $20. She can spend less than $20, but she can't spend more than $20. So her total must be less than $20. And it could also be equal to. Okay, so we can spend up to and including $20. So the overall scenario again is $4.30 per tube. So we're going to write that as 430 times, we'll call it T, needs to be less than or equal to 20, where our variable T represents number of tubes of paint. So we're going to solve this by putting a dotted line through our inequality, circle our variable, and then we're going to go ahead and divide both sides by $4.30. Now, we don't necessarily have to put 4.30. We could just put 4.3. But a lot of times when we're using money, we like to just write it out in the 2 decimal places. So 20 divided by $4.30 gives us T must be less than or equal to approximately 4.65. Now, here's the catch. She can't buy 4.65 tubes of paint. Okay. She definitely can't buy 5 tubes of paint because she needs to buy less than or equal to. Okay, so we're going to have to take this number and we're going to have to round it down because she literally has a fixed dollar amount. So we want to know the possible numbers of tubes that Jill can buy. So Jill can buy, let me get out my little keyboard here so then it's easier and neater. Jill can buy 4 tubes of paint. And let's write the words by up to 4 tubes of paint. That's kind of covering all of our bases. Okay. So she can buy 0 tubes, 1 tube, 2 tubes, 3 tubes, or 4 tubes of paint. Okay. So this is definitely a situation where we have to take into consideration the context of the situation. So T, the tubes of paint, is less than or equal to 4.65. We can't round it up because rounding up to 5 will take us over the $20. So it's got to be less than, so we have to automatically round down, and she's only going to be buying whole numbers of tubes of paint. So if I put this now on a number line, that's not a line, that's a box. If I were to put this on a number line, I'm going to pretend that it's a nice line here. This is actually going to be a discrete situation, and what I mean by that is rather than just shading arbitrarily, because we can only literally buy whole numbers, Okay, so we got 0, 1, 2, 3, 4, 5, 6. The actual graph that will literally represent this situation, this answer, is exactly 4 tubes of paint. Exactly 3 tubes of paint. Exactly 2 tubes of paint. Exactly 1 tube of paint. Or exactly 0 tubes of paint. Some people not thinking about the reality of the situation would just kind of put a closed circle on 4, or they'd go to 4.65-ish and then shade all the way left. Now, technically, you're not going to buy negative tubes of paint. So that's why we're stopping at 0. So she can buy 0, 1, 2, 3, or 4 tubes of paint. If there were lines in between here, if we had shading, that would imply that she could buy, say, 2.5 tubes of paint, 1.5 tubes of paint. So sometimes we will run into whole number only situations, and we call this discrete. And number 12 says a pitcher holds 128 ounces of juice. What are the possible numbers of 10-ounce servings that one pitcher can fill? So the total number of ounces that we've got to work with is 128. There's literally no more than 128 ounces of juice. So we can fill up cups up to and including 128 ounces. Okay. Now, because they're 10-ounce servings, it's 10 ounces per cup. So 10 times the number of cups or servings. So our inequality here will be 10 C is less than or equal to 128. We're going to solve this with our dotted line through our inequality, circle our variable, and then we're going to go ahead and divide both sides by 10. So we have C is less than or equal to 12.8. Now, again, we're talking about the number of 10-ounce servings. So we're not talking about the number of 10-ounce servings or number of 9-ounce servings or just any numbers of the beverage in a cup. We want specifically 10-ounce servings. So C, the number of servings or the number of cups, I'm going to better define my variable. Let C equal number of 10-ounce cups of juice. So we can have up to and including 12.8 cups of these 10-ounce servings, but we don't want 80% full glass of juice. We only want the full 10-ounce servings. So once again, this is going to be a situation where because it's a less than or equal to, we're going to automatically round it down to 12. Okay, so just like this previous problem, let's see, there we can fill up to 12 10-ounce servings of juice. Or the pitcher can fill, sometimes it's just weird writing a sentence. The pitcher. Okay, so we're talking about full servings. So once again, if we're talking about only full servings, theoretically, somebody's going to feel slighted if they get only 80% of their cup filled. Okay, so this would be another discrete situation. So 12 cups, 11 cups, 10 cups. So if I make my number line here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we can have 12 full servings, 11 full servings, 10 full servings, 9 full servings, 8, 7. And I mean, obviously with cups of juice, it's not that big of a deal, but we are trying to be specific about exact 10-ounce servings. Okay, so we're not talking about partial cups, only full 10-ounce servings. So once again, another discrete situation, and we're not going to be dealing with negative numbers of cups of juice. All right, so that wraps up section 2-3. And up next is actually going to be a quiz on sections 2-1 to 2-3.